we want to find a limit x approaches infinity. In the numerator you have a square root of 13x squared plus 9 over 5x plus 3. So if you look at here, x is a positive number and it's a very big number. So when you have that type of situation, you can take only the higher order terms in the numerator and denominator. So higher order in the sense x is large, so 5x we consider higher order, 5x. Now in the numerator, free constants under radical sign, since we have 13x squared, can be ignored. So then you have just square root of 13x squared. So then x squared will go outside as x, and then square root of 13 will stay here. Now you can cancel your x and x. So the limit is square root of 13 over 5. Now I will take this same example, but in this case my x will approach to negative infinity. So what happens here now? My x is a negative number in the left side of 0. So what happens in this case? We'll use the same concept. X approaches negative infinity. In the denominator we take 5x. In the numerator, now x squared will be x and it will come outside. And now since x is a negative number, I need to put another negative to make it positive. And then you will have square root of 13. Now this x cancelled out, and your limit is negative square root of 13 over 5. So let me write it clearly. So see that finally we get negative square root of 13 over 5. So these are the limits. So I want to confirm this using calculator. So I type my function in the calculator. So square root will be on 13x squared plus 9. So we have within parentheses, that's good, divided by 5x plus 3. Now first let me go with the standard window, Zoom 6. So this is my function, and we can see we have a vertical asymptote at, when you write this equals 0, that will give me negative 3 over 5 is 0.6 negative approximately. Now let me take window a little bigger so that I can test for large values of x and then see what happens. Graph it again, and then you trace it at say 99. Trace at 99 and see that the value is coming out like it's a roughly 0.72, you can say 0.72, keep it in mind, and we'll check our answer, this one here. So you go to the regular mode, second mode. Now I use second square root of 13 and I divide it by 5. My answer should be close to 0.72. See, exactly, it is working. The next one we have same almost, we have a negative sign. So let us check that one. Go to the window, make it negative 100, graph it, then trace, and then type negative 99 and see negative 0.72. That's right. So we are done with this. So this is the basic idea. Just careful with your x. If it is positive, when you are taking x squared outside, go with a plus sign. When it is negative, take your x squared outside the radical sign with a negative. That's all. Since x is very large, so we can also apply the concept before you have seen, that higher order terms from each factor we keep. So we have 5x, and then you have 3x, then you have 2x, and then you have 3x. Now when you simplify this one, you can see that this x, all x will cancel out, and then this 3 cancel out. So your answer is 5 over 2. That's plain idea. Number 4, limit x approaches negative infinity. Let me take the same thing. and then we have 2x minus 1, and then we have 3x minus 4. You just do the same thing. Limit x approaches negative infinity. So I will have 5x times 3x, 2x times 3x. We are not simplifying anything on this. Just drop the free constants. And then finally you see that you end up with 5 over 2. So both the cases your limit is 5 over 2, and you can easily verify this in the graphing calculator. I hope it makes sense to you when you find limit, no matter how the function is given to you. If x approaches infinity, then we just take the higher order term. And all these ideas you have learned in pre-calculus, usually known as horizontal asymptotes.